Lesson number 1, daily summary. In this lesson, we review solving equations and graphing. Each lesson's set of notes begins with a demonstration, which will lead you through the basic concepts of that lesson. Then you'll work on the activities, which will give you a chance to practice the new concepts. After the activities, you'll find a section of even more practice problems. The even more practice problems are the only ones in this packet that you are not required to do. Finally, each lesson ends with a quick check, which is a single problem based on the material from the previous lesson. Number 3, unless noted otherwise, the problems in the class packet are intended to be done without a calculator. Consider the equation y equals x plus 4. Fill in the table with 4 solutions to the equation y equals x plus 4. The first row has been done already, so let's take a look at that first row. I have somewhat arbitrarily chosen x equals -5. We plug x equals -5 into the equation, so that's the y equals -5 plus 4, and that's equal to -1. And then we write that as a nice ordered pair, -5, -1. I have also chosen a few other values of x. So pause the video here and then come back once you've filled in those 3 rows. Part B, plot the 4 solutions ordered pairs on the grid. The first point has been plotted already. So -5, -1 is this big old dot right here. And we're going to go ahead and plot the other 3 points on the axes. So -2, 2, that's from the origin here. We got 2 left and 2 up right there. 0, 4, so straight up from the origin 4 units, and then 3, 7, so from the origin 3 to the right, 7 up right here. Part C, connect the 4 points with a straight line. Use a straight edge to help you. So you should use a ruler or something straight. I think I've got a tool here I can use. And you want to just try to hit all 4 of those points if you can, something like that. And part D, which quadrants does this line pass through? And then there's a hint, which tells you the numbers of the quadrants. So number 1 is the top right quadrant. We use Roman numerals for the numbering of the quadrants. And we start from the top right and we go counterclockwise. So 2 and then 3 and then 4. So which quadrants does this line pass through? It passes through quadrants 1, 2, and 3. So the point of this was just to refresh our memories on how we find points that are on the equation of a graph, and then how we plot points. And in this case, we just connected with a straight line. On the next page, we'll review some equation solving. One technique for solving this equation, so this monstrosity is the thing we'll be working on this page. 1/2 x equals 5/3 parentheses x minus 65. So one way is to first distribute the 5/3. There is an alternative solution method that avoids much of the fraction arithmetic required if you first distribute. But let's try the distributing way first. Hopefully I can convince you that it's hard, and then we'll see if we like the other way better. So we distribute this 5/3 through the parentheses. 5/3 times x, that's just 5/3 x. But then to do 5/3 times 65, we need to write that 65 as a fraction. And we know when we multiply fractions, we go straight across. So the bottom is 3 times 1, the top 3 times 65. I guess that's 325. So that goes right there. Next thing we recognize is that there are x's on both sides of the equation. That's a problem for us. So we're going to group these x's together by subtracting 5/3 x from both sides. So when we do that, the 1/2 x stays here. The 5/3 x gets subtracted, so it becomes minus 5/3 x. And we copy this -325/3. Next thing we need to do is combine these 2 like terms. I'm going to make up a simpler example that doesn't have the fractions in it because we know how to do this. We might not know exactly what to do because there's fractions. But if I gave you 7x minus 3x, you would say, oh, that's just 4x. So how did you get the 4x? Well, you did 7 minus 4, and then you tacked on an x at the end. And so this is exactly the same pattern that we have. What we're supposed to do for 1/2 x minus 5/3 x is subtract those numbers. They happen to be fractions, but they behave just like the 7 and the 4, and then tack on an x at the end. And now we have this whole separate problem. How do we subtract 2 fractions? Well, first we need a common denominator. So the lowest common denominator for these two fractions is 6. And so we take the first fraction and figure out what to multiply the bottom by to get a 6. So this one here, you need to multiply by a 3 on the bottom. So we multiply by 3 on the bottom to make 6, and we multiply 3 on the top because we have to do the same thing to the top that we did to the bottom. So that's a 1 times 3 upstairs. Minus, then we look here and multiply it by something to make the same 6. So we multiply the bottom by 2, and therefore the top by 2 as well. So let's multiply the bottom by 2, give 6, multiply the top by 2, 5 times 2 is 10. And then now finally we've done all that work to make a common denominator. And so then we get to subtract the numerators together. 3 minus 10 on the top, and then just a single denominator of 6 on the bottom with an x on the outside. And then altogether that is negative 7/6x, and that is right here. Okay, so hopefully we weren't too intimidated by the fractions there, but I do like this idea of if you're not quite sure what to do because the numbers are frightening, maybe just make up some not frightening numbers. And probably the technique you know for the not frightening numbers is going to work for the frightening numbers. Okay, so next up, how do we solve this equation here for x? Well, there's a negative 7/6 multiplying by our x. So one thing we could do, I'm going to erase this in a second, but one thing we could do is divide both sides by negative 7/6. That will get the x by itself. But it also puts us in this unfortunate position of having a fraction over a fraction. Now, it turns out there's a way to get out of that position. There's a technique that you can use to fix that thing and make it so it's just one plain old fraction with just an integer on top and an integer on the bottom. But in this class, we're not going to talk about that technique at any point. So I don't want to paint ourselves into a corner here because we don't have a way to get out. So a better alternative for us this semester, instead of dividing both sides by a fraction, we're going to multiply both sides by the reciprocal. Multiply both sides by negative 6/7 in this case. I put the negative upstairs. It doesn't matter whether it's upstairs or downstairs or in the front. Let's put it in the front. So why is that helpful? I don't know, but it's allowed, right? Because I'm doing the same thing to both sides. But if I multiply both sides by negative 6/7 on the left-hand side, the 6's cancel and the 7's cancel and the negatives cancel, and we're just left with one x, which is exactly what we wanted. Okay, so then the left-hand side is plain old x. The right-hand side is this product right here. And so the question is, how do we multiply two fractions? So to multiply two fractions, do we need a common denominator? No. To multiply, you just multiply straight across. But before we multiply straight across, we want to reduce. It's in our best interest to reduce before we multiply. Looking for any denominator that cancels partially with any numerator. I see a 3 on the bottom and a 6 on top. I can make a 1 there and a 2 there, and that's as good as it's going to get. Doesn't matter that they're part of separate fractions. So 325 times 2, that's 650. There were two negatives in the front. They cancel and become positive. And then 7 times 1 on the bottom is just 7. So there's our answer, 650/7. That is the right answer. Nothing wrong with what we've done there. But let me give you an alternative, which personally I think is a whole heck of a lot easier than what we just did up above. So the reason that the technique we used above was complicated is because we immediately took this 5/3 and distributed it. We made more fractions, and we also had that 1/2 fraction to deal with. Let's get rid of all the fractions at the get-go. From the get-go, I should say. We are going to multiply both sides by the lowest common denominator of all the denominators you see. There's a 2 and a 3, so the lowest common denominator is 6. I'm actually going to write it as a 2 and a 3 instead of writing it as a 6, but it's okay to write it as a 6. It might not be clear why we're doing that, but again, at least it's legal, right? Because we're doing the same thing to both sides. On the left-hand side, this 2, or let me just make clear, these are on the top. They're firmly on the top, not on the bottom, not both top and bottom. So on the left-hand side, the 2's cancel, right? There's a 2 down there and a 2 up here, and they go away. And on the right-hand side, the 3's cancel, that 3 and that 3. And so all that we're left with is what's written right down here. Nope, not there. It's written right here. 3x, that's this thing. And then the 5 times the 2 will make 10, that's there. And then the x minus 65 is copied here. And that that equation looks a whole lot friendlier to me because it has no fractions anymore. And the rest of this is going to be a piece of cake because we did the hard part. We got rid of the fractions by multiplying both sides by the lowest common denominator. One common mistake I'll point out. Some students want to take, so let me go to this next line here. So I'm going to cross off this 3 and this 3, and I'll focus on what's left here. Some students want to take the 2 and give it to the 5 to make a 10, which we did, but also give it to the parentheses, like give it to the x and give it to the 65. And that's no good. Once the 2 smushes into the 5 to make 10, the 2 is used up. It would be like this, 2 times 3 times 4. That is the form of this thing right here. It's 3 things multiplied together. So you're perfectly welcome to do 2 times 3 and make 6. But you don't then give the 2 to the 4 and make it an 8, right? The 2 is used up. Okay, so moving on. The rest of this hopefully is straightforward. We distribute the 10. 10x minus 650. Again, x is on both sides. We need to get them together on the one side. So let's subtract 10x from both sides here as well. And then we're left with negative 7x equals negative 650. And then finally divide both sides by negative 7, and we get 650 over 7. How does that compare to the answer we got up above? Well, of course it's the same, right? Everything we did was valid. But just putting out there, if you have an equation with fractions in it, it is your right to get rid of those fractions by multiplying both sides by the lowest common denominator. Okay, move on to the activities on the pages that follow, and good luck.